Alright, today I'm going to talk about prime factorization and greatest common factor, which is abbreviated GCF, and greatest common divisor, GCD. First of all, if you have a fraction such as 40 divided by 60 and you wanted to reduce it to its lowest form, you would want to find its greatest common divisor for both of these numbers. So I'm going to show you a method for going about finding that. First of all, you see I put 40 here and 60 here, and I'm going to factor each number. As I factor, I want to try and pull out a prime factor along with a composite factor. So I'm going to start with 2 and 20 for 40, and I like to arrange it so that all my primes are on the outside edge. So now I'll do 2 and 10, 2 and 5. Okay, and let's do the other number. I have 2 and 30, 3 and 10, 2 and 5. Now what I want to do is identify my prime factors. Okay, so this one's prime, this one's prime, this one's prime, this one's prime. Over here, this one, this one, this one, this one. So by always arranging so your primes are on the outside, it makes it easy to identify them later. Now what I want to do is, that was my phone ringing. Now what I want to do is identify the factors that are in common with each other. Okay, so I've got 2 and 2 and 2 and 2 and 5 and 5. Notice I skipped the 2 and the 3. That's because 2 and 3 are not the same, so they're not in common. So I'll just cross those out because I don't need them for this purpose. Now, my prime factors are 2. Notice I put the multiplication symbol between them. Over here, the same, because we're looking for what's in common. 2 times 2 is 4, times 5 is 20. So, this would be the greatest common factor of both of these numbers, or we can call it the greatest common divisor. So up here with this fraction, if I wanted to reduce it, I could divide the numerator and the denominator by 20, and I would get 2 divided by 3 as my lowest term for that fraction, which we call rational numbers. Okay, let's look at another example. This value has variables in it and exponents, and this one does too. So the method I would use to go about finding the greatest common factor for values with variables is a little different. Okay, first of all, my 7 isn't going to change because that's prime already. This would be 7 and 2. So I'm going to go ahead and identify what's in common with the numbers here. And I can go ahead and highlight that. Then I will cross off what's not in common and move on to my my first variable, which is n. Okay, so how do I want to go about factoring these? And I want to remind you of something. Let's take 40 for example. I could start factoring this 2 and 20, or I could start factoring this 8 and 5 and then branch off from those numbers that are composite. So bottom line is, for the same number, I could start factoring it different. Well, the same is true for variables with exponents, such as n to the 4th could be n times n times n times n. Okay, I'm going to use parentheses to kind of show you. One way of factoring this would be n squared times n squared. Another way of factoring this could be n to the third times n. So again, I could go about factoring the n to the fourth different, n squared times n squared, or n to the third times n. Well, look over at your other n and see how what you're dealing with, and so that'll help you determine. I'm going to use the n squared times n squared because in this case I'm not going to factor this one out. I'm just going to leave it n squared because I'm trying to find the greatest common factor. And anyway, and then I'll cross off this other n squared. So this variable has n squared in common. Now what about the last one? Well, this is just an m, and this is m to the third, so it's obvious to me I need to do m squared times m, and identify this and this as what's in common, cross that off. Now I can write my greatest common factor for these two that have variables. So it would be 7 times n squared times m. Okay, so that would be my greatest common factor or greatest common divisor. So later on, if this were set up like a fraction, and I was asked to reduce this, well, I could set up like this and do this technique like I did, or later on you'll learn another technique for how to reduce this, but for now I could say these would be divided by 7n squared m, 7n squared m, and then basically 7 divided by 7 would become 1, so when you have variables it's just kind of that invisible one. And then n4 divided by n squared would be n squared. M divided by m would be 1, so we don't put the 1 because it's like 1 times n squared. And then 14 divided by 7 would be 2, and n squared divided by n squared would be 1. M cubed divided by m would leave m squared. So my final reduced answer would be n squared divided by 2m squared.